Letitia H writes, how many zeros can the polynomial 2x squared minus 3x plus 4 have? Well, I've got a short and a longer answer for you, Letitia. The short answer is short. So let me show you what it is. I'm going to share my screen for a moment so that we can use my fancy technology here. And let me rewrite the polynomial real quick, just the way that we would actually see it in our textbook. 2x squared minus 3x plus 4. There we go. Now, here's what I can tell you. If this is the highest degree, and in this case, it very clearly is x squared, I have x to the 1. I could say this is x to the 0 because anything to the 0 power is just 1. If this is the highest degree, and it is, this is how many roots I have in my polynomial, or for this function, this polynomial function, per the fundamental theorem of algebra. That's the short answer. If you can put them in the right order, you can at least find the highest degree, that's how many roots you should have. And you might ask yourself or wonder, well, what if I'm factoring some other, not this one, but some other polynomial, and I get something like x minus 1 squared equals 0, and I solve for it, and obviously I get x equal to 1. Well, where did my other root go? This is clearly just one root. Well, it may look like it, and even if you graph it, you'll see that that 1 is sitting right there on the x-axis like so. So it may look like there's only one root, and this would be the case if it were x equal to 1. But what you're really doing is you're saying that x minus 1 times x minus 1 is equal to 0. And given the zero product property, that means each of these is in turn equal to 0, and so forth. So I think you can see where I'm going with this. So what this means is that, in part, it's still following the rule. What we do is we call this a multiplicity. We say 1 multiplicity, I'm not going to spell the whole thing, multiplicity 2, meaning that we have a root of 1 twice, so to speak. So even here, you will always have 2 roots, no matter what. You can't get this one wrong. Now, what if you wanted just a little bit more information? I would love to get into all the ways you can figure out how many positives and negatives and imaginaries there are, if there are any imaginaries. But here's one quick thing we can do. If I can't factor it, and I can't see how I can, I can do 2 times 4 is 8, and there's no combination of 8, 2 numbers that multiply to give me 8 and added together give me -3. I can't think of any. So instead, what I'm going to do is a little trick with the discriminant. Now, if you remember the quadratic formula, or at least have heard of it, -b plus or minus the square root of b squared minus 4ac divided by 2a. Don't worry, we're not going to calculate this whole thing. The part we care about is this. We can actually use this guy to figure out what kind of roots we have. So if I take b squared minus 4ac, and I find it's negative, keep in mind the square root of a negative number is an imaginary. So I would automatically know if this were negative, whether they were imaginary roots or not. And if I have 1 imaginary root, I have 2 imaginary roots. They always come in pairs. That's the secret. And I won't explain why at the moment, but trust me. So b squared, let's take b, -3 squared minus 4 times a, which is +2, c is +4. -3 squared is 9 minus 4 times 2 is 8 times 4 is 32. And I don't even care what the answer is at this point, because the point is that it's negative. It's going to be negative. That tells me for sure there must be 2 imaginary roots. There are no solutions around among the real numbers. They must both be imaginary. So impress your teacher by not just knowing how many roots there are, but what kind of roots they are. So I hope this was helpful, Letitia, and please do let me know if there's anything else I can do to be of service. Have a great day.